And this is all going to be kind of review of everything I just explained here in these slides here. The glomerulus network of capillaries contains blood to be filtered to remove the excessive water, to remove the excessive electrolytes. Okay. Then we have the way the endothelium is in the glomerulus, at least where the cells on top of the glomerulus form this, what we call podocytes. I'll show you what that looks like in a moment. You know how we have macrophages? We've been talking about them. Macrophages in the liver are called what? Kupffer cells. Good, good. All right. Macrophages in the lungs, they're called dust cells. Oh, yeah, it's an easy word to say, that's why. Okay. Now macrophages in the kidneys are called mesangial cells. Okay. Nothing new with that. And then we have the parietal and visceral layer, and I'll show you what that is. And we have these podocytes creating that in these filtration slits. So let me show you what I mean by this. What you have over here, you're going to have podocytes, and podo means feet. So these cells have these little feet on them. And you have the podocytes all around on top of the glomerulus. Okay? And what they look like at a close-up, there's a podocyte. It has these little feet. And there's another podocyte underneath it. And there's another one over here and so forth. They get very close. We have fenestrations, as you learned in circulation. You have fenestrations in the capillaries, allowing certain things to go through. But the way that the podocytes are set up, they're even going to limit more things or less things to get into the kidney. So you have these holes here, these fenestrations, but the way that these feet go, they kind of interlock with each other, allowing that, and in between each one of the podocytes, you have these what we call filtration slits that are going to really restrict what can get into that nephron. Does that make sense, how this is all set up? Okay. This here, the podocytes, is the visceral layer. The parietal layer of Bowman's capsule is going to be out here, which is going to be simple squamous epithelium. So visceral layers around here, parietal layers around here. Again, that's chapter 1 stuff. You have to go back to all this kind of stuff. Okay? These are the endothelial cells that are on top of the capillaries. All right, the glomerulus. And in this model here, see these white stars over here? Those are the podocytes. Okay? Does that make sense? Whoops, that's not good. This here, similar one. Okay. You see the podocytes on here? The beige area. It should be covering all the glomerulus, but they're only showing you half of it being covered by the podocytes. But they should all. And when you get close, you'll see the filtration slits on here and all. So let me just show you what's going on with this model. Okay, you can see this is the coronal cut of the kidney. You can see the cortex. You can see the medulla. You'll see the renal pyramids, the calyxes here, minor and major, the pelvis, and you can see the ureter. If we get a close-up of this section here, that's what this is here. I got it, thanks. So what you got over here is a section here. This is the cortex. This is the medulla. When you get up closer, you can see the whole. You can see the renal corpuscle over here. When you get up closer, you'll see it. You'll see a cross section of one. You can see the glomerulus. You can see the Bowman's capsule. Follow it. There's the PCT, the loops of Henle, the DCT, and you can see the collecting ducts. Okay? We can get a close-up of one of these renal corpuscles, and that's what this is over here. And we're going to get into this because we've got to talk about this, how the DCT touches the capillary, or the arterial. All right? So this is Bowman's capsule. So what is this? The PCT, proximal convoluted tubule. Okay? We got 4 of these models. I guarantee this is going to be on your practical. Okay? I like it, she likes it, we all like it. There's a lot of things you could ask on this. Okay? We'll get back to that one. Okay. So you can see afferent, efferent arterioles over here, the glomerulus. You can see the podocytes on here. Okay? What is this over here? What tube is this? PCT, right? So what are all these circular things? Those are, remember, you're only looking one glomerulus in the kidney, but in a kidney there's millions of capillaries, millions of nephrons in one kidney. So these are cross sections of all the different tubules. If I take a slice here, right through this whole thing, I'm going to get a cross section here, a cross section here, a cross section here, a cross section here. That's what you're looking at, is the cross sections of all the tubes that are surrounding here. Okay? And you'll be able to see this with a microscope. All right? You won't be able to see podocytes. I won't ask you that. I'll show you that in a moment. But you have here, this is your glomerulus. Okay? And you'll get to visualize a little bit more, but the way I see it is like it's dangling. It's like this. See how like it's attached up here, and then it's a, I don't know, cluster of grapes kind of thing that is dangling from here. And that's what I'm seeing over here, is that it's attached here and then it's dangling out there. Do you see that? Okay? So if that's so, then what would be located in this area here? PCT. It's the opposite. Okay? You'll also see a space in between the glomerulus and Bowman's capsule. This space is called the urinary space. It's also known as the Bowman space. And again, when lecture, you'll get into the Starling's forces again with hydrostatic pressure and osmotic or oncotic pressure. That's what it's all going to be dealing with again. You'll be using the word urinary Bowman space there. Physiology. Okay? Proximal convoluted tubule. Well, Bowman's capsule, as you said before, is going to have simple squamous epithelium. Here, it's going to be simple cuboidal cells. And you're going to have tons and tons of reabsorption. So you're going to have many microvilli there. When you see microvilli, you know there's some form of absorption or reabsorption occurring. You learn that from digestive system, okay, in the small intestines. So you're going to have tons of microvilli there. And like I said, what occurs in the PCT is most reabsorption, specifically 65% reabsorption, including 100% of amino acids and 100% of glucose in a healthy person. The loop of Henle, there's different parts to it. Basically, the descending part has a thick part here, which looks exactly like the PCT, except it's not convoluted, it's straight. So you're going to have simple cuboidal cells over here, you'll have simple cuboidal over here. It's just straight though. Then you have the thin area here, and that's going to be simple squamous epithelium, thin. Then you'll have the hairpin turn, and then you'll have the ascending, which kind of works the same way. And this is going to be simple squamous epithelium, and then this is going to be simple cuboidal. It'll look exactly like the DCT, except it's straight. Functions, as I said, water gets reabsorbed in descending, but the solutes, the salts, don't. They do insignificantly. We're talking about less than 5%. Okay? Going on the hairpin turn, that's where it's most concentrated, as I explained to you. Ascending wise, water cannot pass through it, so it's impermeable to water, but salts can. All right? They get reabsorbed. The DCT. When you compare it to the PCT, I'm not drawing the scale, but this is shorter than that. Okay, the DCT is shorter. It has smaller cuboidal cells, and there's fewer microvilli there. There is microvilli. There's going to be reabsorption, but not as much as you would see in a PCT. And that's what's going to be the hallmark for you to actually determine between a DCT and a PCT. You're going to be able to see the amount of microvilli there. I'll show you that on the microscope. Remember, aldosterone is going to target here. Now, I have to say to you that what hormone targets this mostly is aldosterone. But some ADH does target here. Not a lot. Same way here. In the collecting duct, most ADH is going to go here. A little bit of aldosterone goes there too. So it's all in the words on the practical exam and your lecture exam. If it's asked over here, what hormone mostly targets here? You can't say ADH because she said the word mostly. Okay? And the collecting duct, as I explained to you, we have water reabsorption and we have ADH that's flooding that area over there. Okay? So far so good? Histology slides. Really there's only one, the kidney. You'll see over here a cross-section of a tube. You'll see over here a cross-section of a tube. You're not going to have the letters on there. Inside the lumen, you see there's a lot of gunk there. In this lumen, there's not much gunk there. What is that gunk that I'm talking about? Not filtrate, no. The microvilli. That's the microvilli here. It's loaded with microvilli. This one doesn't. So this has to be the PCT. That's the DCT. Okay? Does that make sense? Now, I'm going to make it easy for you. Because on my practical exam, I'm going to say, what is this, not this? I'm going to say, not that, sorry. I might say, what hormone targets mostly here, not here? So you should be able to compare the amount of microvilli in there to determine is that DCT versus PCT. Okay? You could definitely say this is kidney. You could see the glomeruli around there. You could see that this is kidney. And you could also appreciate how if you could see it, see how it looks like it's dangling. It's attached over here, but it's dangling out there. It's attached here, but it's dangling out there. It's attached over here, but it's dangling out there. Okay? It's attached here. This one is pretty good because I've never seen it like this except in this picture from online. But here's where a PCT is. Okay? You'll see here Bowman space or urinary space around here. Okay? See how it looks like it's dangling? All right? So that's the glomerulus. Let me ask you this. What is it from here to here, including the white space? What is it from here to here, including the white space? What is that called? Yep, that's the renal corpuscle. What is it from here to here, not including the white space? Glomerulus. You see? All right? Not too bad?